Why do astronomical observations use different wavelengths of light? Imagine trying to understand a story by looking at it through different lenses. Each lens reveals a new part of the story that others might miss. That's what astronomers do when they use different wavelengths of light to study space. The universe is full of mysteries, and each type of light tells a different part of the story. The electromagnetic spectrum includes gamma rays, X-rays, ultraviolet light, visible light, infrared light, microwaves, and radio waves. These are all different kinds of light, each with its own energy level and wavelength. Gamma rays and X-rays come from super-energetic events like black holes or exploding stars. They help scientists see the most violent and energetic parts of the universe. Infrared light has longer wavelengths and can pass through dust clouds that block visible light. This allows astronomers to see stars forming inside dense clouds that look dark in visible light. Ultraviolet light is emitted by very hot objects like young stars and energetic phenomena. It helps scientists study how stars are born and how they evolve. Radio waves have the longest wavelengths and can reveal cold gas clouds and large structures in space. They also help detect the cosmic microwave background radiation, which is the leftover heat from the Big Bang. Earth's atmosphere plays a big role in what we can see from the ground. Some wavelengths, like visible light and certain radio waves, pass through the atmosphere easily. But others, like X-rays and most infrared light, are absorbed by the atmosphere. That's why space telescopes are used to observe these wavelengths. They orbit above the atmosphere and can gather data that we simply cannot get from the ground. Using different wavelengths together gives a more complete picture of what's happening in space. For example, combining visible and infrared images of a nebula shows both the glowing gas and the hidden newborn stars inside. This approach helps scientists understand the composition, temperature, and movement of objects in space. Supporting observations across the entire electromagnetic spectrum is important for scientific progress. It helps us learn more about how the universe works and keeps us at the forefront of space research. Investing in space telescopes and ground observatories that cover different wavelengths not only advances science but also boosts technological innovation. It inspires new ideas and creates practical tools that benefit everyday life. In the end, each wavelength of light acts like a different piece of a puzzle. When put together, they reveal the full story of the universe's many wonders. This is why astronomers use a variety of wavelengths to explore the cosmos, unlocking secrets that are invisible to the naked.